We've talked a fair amount about classes, and we've talked a fair amount about good code structure and the importance of having clean code that is simple and straightforward and understandable, and also that avoids duplicating code, which is a big no-no because that's one of the easiest ways to introduce a lot of errors. So what happens when you start to design classes for more complex architectures, more complex systems, where you have a lot of similar kinds of classes that do similar kinds of things, and yet you want to avoid duplicating code? It turns out this is a surprisingly common problem. For example, suppose we wanted to make a class that represents, say, a clock. Just something that has the current time. And now suppose you want to make a specialized kind of clock, like an alarm clock. Well, an alarm clock is a clock, right? I mean, you have to store the time, but you also have to store when the alarm is set and whether the alarm is on or not. So if you want to make a clock and an alarm clock, how do you do it so you don't have to duplicate the portion of the code that represents the current time? It turns out this is a really simple example, but this basic problem comes up over and over and over again. Let's draw a little picture to get a clearer sense of exactly what the issue is and how we can go about addressing it.
Okay, here's what we're trying to do. We're trying to define a basic clock class that has just a simple thing like time, right? An instance variable. And then we're also trying to define an alarm clock class which has time, and it also has the current alarm. They might also have some utility methods for getting and setting the time and the alarm. The challenge is, how do you define alarm clock so it takes advantage of the coding you've already done with clock, especially the instance variable time and the getter variable? Well, the solution is not to have two completely separate classes, but instead to define a base class of clock and an alarm clock that is a subclass. So let's pick a different color. And instead of having alarm clock on the side there, what we're going to do is define alarm clock below it, and say that alarm clock inherits from clock. So it is a clock, and we often say that this is an is-a relationship because an alarm clock is a clock. That is, it both has the semantics of a clock, it has the instance variable of time, and it has whatever methods clock has. Then we can define just the things in an alarm clock that aren't in clock. When we do this, we often typically use a lot of common words to define what clock is and what alarm clock is. The clock on top is the base class. It's also called the superclass or the parent class. These are all equivalent words, and they mean the thing that you are inheriting from. The alarm clock, on the other hand, is called the child class, or the subclass, or the derived class.
Now let's go ahead and see what it actually looks like to code one of these subclasses with inheritance in Python. So we're going to go ahead and start from scratch and make a new file. I'll call it clock, and we're going to go ahead and see if we can implement the basics of what we just saw. We're going to start by defining a new class called clock, and it's going to have a constructor as usual, and we'll take a single parameter, which is the time. And we'll set up an instance variable called time, set it to that parameter that we passed in. And let's make a simple getter that returns the current time. All right, that's pretty straightforward. Now we want to go ahead and define a new class called an alarm clock. This is where it gets cool, right? We're going to make an alarm clock that is a clock. So remember how our class definitions always have these parentheses, and I said we would talk later about what that was for? Well, now is when we get to talk about it. The thing that goes in the parentheses is the parent class that the current class inherits from. So if I put clock inside of these parentheses when I'm defining the alarm clock class, that doesn't mean that I'm not calling the alarm clock function, I'm not calling it a method. Clock isn't a parameter. It's a little tricky because it looks like a parameter to a function, right? We're putting something inside of a parentheses, and that's how we normally use parentheses in Python. But because we are defining a class, in this case what this is saying is that alarm clock is a new class and it inherits from clock, which means it essentially is a clock. It is everything that clock is. It is the clock's constructor, its instance variables, its methods, and whatever else we define in alarm clock. So for example, let's define its own constructor and pass in not only the time but also the alarm. Now what we can do is set the time and set the alarm, right? We're going to create these two instance variables. Well, we're just setting time and we're defining this new instance variable alarm. And now we can define a getter for alarm where we return the alarm. If we do this, we can now demonstrate how this works. Let's make a few instances of clocks and alarm clocks. So we'll say that clock 1 is a clock and its time is, say, 9 a.m. Clock 2 is a clock and its time is 11 a.m. Now let's make some alarm clocks. I'm going to put these in some variables that start with A just for make it easier for us to remember which is which. A1 will be an alarm clock whose time is 1 p.m. and whose alarm is 3 p.m. And A2 is going to be another alarm clock whose time is 2 p.m. and whose alarm is going to be set for 5 p.m. Now we can go ahead and make a list of clocks. We'll just put all of these clocks instances that we just made in that list. Now let's go ahead and let's do something for every clock. And this is the magic of inheritance, because we can iterate over this list. So clock is going to first be C1, then C2, then A1, then A2. But the point is, for every iteration through this list, clock is going to be a reference to one of those clocks. Sometimes there will be clock, and other times there'll be alarm clock. So we can, for example, print the clock's time for each one. Let's go ahead and run this and see what happens. And what we get is it prints out 4 times: 9 a.m., 11 a.m., 1 p.m., and 2 p.m. And sure enough, those are the times for our 4 clocks. But notice when we defined alarm clock, we never defined a getTime method. The reason this worked is because the getTime method came from the parent class from clock. Okay, now it gets a little bit trickier. Suppose we want to get the alarm time. Well, if we just tried to print the alarm time, that's not quite right, is it? Because clock might be a clock or it might be an alarm clock, and only the alarm clocks have alarms. So if we called getAlarm on an instance that happens to be a clock, it doesn't exist. So that's going to be an error. And when we run it, we'll see that. Sure enough, it printed out 9 a.m., which was the time, and then it tried to get the alarm of the first clock, and it gave us an error. Clock instance has no attribute getAlarm. So we have to do something to recognize that we are looking at alarms. One way to do this, and I will tell you this is actually not the best way to do it, and we're going to come up with a better way before long. But right now, one of the ways to do this is to check to see what kind of clock we have. And we only will call getAlarm if the current instance is an alarm clock. And the way we can do that is with the type function, which is a built-in function where you can pass in any object and it will tell you what kind of object it is. So we can say if type of clock is an alarm clock, then go ahead and execute this method. So when clock is a regular old clock, this will return false because type of clock will be clock, it won't be an alarm clock, and it won't execute this method. Now, I do have to warn you, in order to use the type function on classes, we actually have to modify the way we define our classes a little bit. When we define our base class, that is the one that doesn't inherit from anything, we actually have to give it a special superclass, a special parent class called object with a lowercase o. And that actually is an instruction to Python that we're using the newer kind of Python objects. You know, we're using Python 2.7 right now, and it's gone through many years of iterations. And somewhere along the way, they actually changed the way their classes worked a little bit. And it's a little bit kind of strange way to do it. But in the old way of using Python, you didn't have to have your base class inherit from object, but type didn't work in the same way. So if you inherit from object, then we use the new kind of class system and type works properly. Let's do one last thing, which is just to make this print out a little bit prettier and say, here's the alarm. Now let's go ahead and run this, and look what we get. We get a first clock that's 9 a.m., a second that's 11 a.m., a third one that's at 1 p.m. with an alarm that is set at 3 p.m., and a fourth one that has a time of 2 p.m. with an alarm set at 5 p.m. So we have got a perfectly functioning clock and alarm clock, and we can use it in just the way we want. We can do a little bit better, so let's go take a look at that.
So when we wrote the kind of code we wrote before, for example, C1 equals clock and A1 equals alarm clock, what does that look like in Python memory? Well, let's take a look. We know that C1 and A1 are variables, and so they are going to be allocated a little block of memory. We know that they are referencing instances of classes, so they're very likely to point to something that is allocated, right, for a class. And we've already done something a lot like clock before, so that's pretty straightforward. Clock is going to be an instance of a clock class, and it has a single instance variable in it, which is time. And time holds a string, so it's really going to be a reference to some string, like 9 a.m. And when we make an instance of that clock and assign it to C1, what we're doing is telling Python that C1 is a variable whose value is the address of an instance of a clock. Right? We've done this before. Now what does alarm clock look like? Well, it's almost the same, but instead of alarm clock being a simple class, it contains essentially inside of it a clock, because it is a clock. Right? Remember, that is a relationship. And then in addition to that clock, it also has the new stuff that makes it an alarm clock. So a clock has a time instance variable which references some string, like 9 a.m. And in addition, the alarm clock has an alarm instance variable, which is a reference to another string. In this case, it's the alarm time, which maybe is 2 p.m. That's also of type string, and A1 points to one of these things. So now when you say something like clock equals C1, and then you say clock dot get time, what you're doing is calling the method that is defined inside of clock. Now, we didn't draw the functions, the methods, inside of our memory representation because we haven't been doing that so far. But the method is associated with an object of type clock. And so when we use this dot, we're saying access the instance referenced by the clock variable, which in this case is the same as C1. We're accessing the reference in clock, and we can access the getTime method that's in here. The same thing happens if instead of saying clock equal to C1, we had set it to C2. Sorry, to A1. Now we're referencing one of these alarm clocks. And when we want to call its getTime method, that's okay, because an alarm clock is a clock and it contains a full instance of a clock. And so we can access the getTime method inside of this clock instance.